Hey guys, and welcome back to another one of the A-level maths tuition sessions that I'm doing on YouTube. So today we're going to be covering the vectors, so specifically 2D vectors today. So with 2D vectors, there's a few different kinds of questions that can be given to you. So I've got a bunch of exam questions here and some questions from the most recent exam papers as well. So first of all, we have given that the point A has position vector 3i plus 4j and point B has position vector minus 4i plus 7j. Find the vector AB. So one thing to note is that in A level we move on from using the column notation and we start using the IJ notation as well. You're going to use this in mechanics especially as well, so just you need to get very familiar with that. What I would like to do here though is to make it a little bit easier is we can actually turn those vectors into column notation just for the purposes of calculating. In this case I believe it's easier, but in some other cases it might be could be trickier, but we'll leave it as this for now. So to get A to B, what we do is we take vector B and we subtract vector A from it. So we're doing this minus this. Minus 4 minus 3 will give me minus 7. 7 minus 4 gives me 3. So if you wanted to write that out in IJ notation, it's just minus 7i plus 3j. Nice and easy. Now part B is it asks you to find this, but it has the modulus signs around it. Now the modulus signs means we're basically taking the magnitude of these vectors. Basically it's the size of the vectors, okay? So the way we do that is we use, essentially it's Pythagoras, right? We do square root and we just square the two components and add them together and then take the square root. So I have the calculator here. Take the square root. You have minus 7 squared plus 3 squared, which gives you square root 58. And generally speaking, you can just leave magnitudes in surd form, and this is true for mechanics as well. That's it. So 4 marks, really not too shabby, I think. Question 2, this is where it gets a bit more interesting. So we have 3i plus kj. Now if we take the modulus of this, we get 3 root 17, so we need to find the value of k. So remember, when we take the modulus of something, we square the components and add them together. So they're saying that this, and once we square root it, should equal 3 root 17. So to solve this, simple, square both sides, so we get 3 squared plus k squared. And if we were to square this, we're going to get, to be honest, you can use a calculator, you don't need to do it in your head. Mental maths is for losers. Whoops. 153, nice and easy. So then minus 9 squared from both sides, so we're basically minusing 9 from both sides, so that's 144. So k is equal to plus or minus 12. Okay, don't forget, especially in A level, we really need to remember the plus minuses whenever we square root a value. So there are 2 values that it could have been here. Okay, and this is also going to be very important for you to remember. Remember, there's always going to be 2 values, especially because we took the modulus. Okay, so when you take the modulus of a function, for example, it makes everything positive, right? So we need to keep in mind that there are always 2 values. Moving to the next one, again we have something that's very similar, so let's just smash through this as quickly as humanly possible so we can get on to the more interesting exam questions that are coming up. Once again, for the vector AB, all you're doing is you're taking the vector B and subtracting the vector A. So we have minus A, 2, minus 5, and 7. And again, I prefer using the column notation instead of the IJ notation, just for calculations, because it helps me keep all the numbers in line. So minus 8 minus 5 would give me minus 3. 2 minus 7 gives me minus 5. And so if we were to write down IJ notation, it's minus 3i minus 5j. And then finding the modulus shouldn't be too tricky. All you need to do is square the two components and add them together. Okay. So again, if any of you have any questions, please let me know, but I think so far it's not too bad. Again, we're just going through the basics at the moment, but we have some exam questions coming up in a second. Wow, I really forgot to put the number in, eh? There we go. That makes more sense. Root 34, and again, in the exam, in mechanics as well, so mechanics and pure, this comes up, you can leave your answer in terms of surds. You don't really have to round these. Okay. Here we are, getting on to something slightly new. We have two vectors. Given that the resultant force of vector A and B is minus 2i minus 3j, find the values of x and y. So resultant vectors are when you add vectors together. So what they're basically telling me here is that minus 5i plus 7j plus xi plus yj should give me minus 2i minus 3j. Because again, resultant vectors are when you add vectors together. So what I'm going to do here is I'm going to gather the i's together. So we have minus 5 and we have x. So I could write that as minus 5 plus xi. And that's just to keep the i's together. Okay? And then I can keep the j's together by doing plus 7 plus yj equals minus 2i minus 3j. So hopefully that makes sense so far, but again, do let me know if it doesn't. So if you haven't come across this trick before, the I and j components are completely independent of one another, right? So the number in front of I here should equal the number in front of I here, and the number in front of j here should equal the number in front of j here. So this is called comparing coefficients. So if we compare I, we have minus 5 plus x equals minus 2. Add 5 to both sides, we get x is equal to 3. Nice and easy. This comes up a lot when we do vectors in mechanics and in pure. So it can come up in two sets of your exams. We have 7 plus y equals minus 3. So then y is equal to minus 10. So there we are, we're done. Okay. Any questions about that? If not, that's fine. Okay, I think that's perfectly fine so far. So we have got some more exam questions coming up. Okay, so we have a triangle A, B, C. So this is where things get a bit more interesting. It can be good to actually draw out a diagram as well. So, for example, we don't know what this triangle looks like exactly, but that's totally fine. Just draw a generic looking triangle, call that A, call that B, call that C. It tells me that the vector A to B is 6i plus 2j, and the vector A to C is 8i minus 5j. And we need to find the vector BC. Well, BC is just going to be AC minus AB. Okay, just because of how the way vectors work. So, doing this, we can use the column notation once again. So AC was 8 and minus 5, minus AB is 6 and 2, 2, or in other words, 2i minus 7j. Okay. Perfect. And then it just says find the length of the line AB. So the length of the line is what I mentioned before. It's simply the modulus of the vector AB. So it's just going to be the square root. So again, they like to kind of ask you the same thing in a different way. because it allows us to, that's just root 40, I don't need a calculator. Because what that allows them to do is to determine whether or not you understand what you're doing, right? So instead of just asking you to work out the modulus, they say find the length of the line. Because what they want to know is, do you know what the modulus gives you? It gives you the length of the vector, right, or the size of it. Okay. Yep. So three forces act on an object. So again, this is a very stereotypical mechanics question. Find the resultant force. Well, resultant force is just the sum of all of the forces, okay? So all we're going to do is literally add all of these together. So again, I'm going to do it in column notation because it makes me feel better. But you can just add up all of the i's and j's. That's also completely valid. Of course it is. So -5 plus 4 is -1. Plus 3 is 2. 7 plus 6 gives me 13. Minus 5 would give me 8. Or we can write that as 2i plus 8j. Not too shabby so far. Again, another very stereotypical mechanics question, but this was actually from a pure paper. But again, the comparison between the mechanics and the pure stuff, it's basically the same. Okay? Very, 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 very similar. So, velocity of 7i minus 5j, find the speed of the car. So, here's where you need to recognize the difference between vectors and scalars. If I take the magnitude of the velocity, I get the speed. So it's simply just equal to the square root of 7 squared plus 5. And that's it. Okay? The same thing if they may give you like an acceleration as a vector, but you can also work out the acceleration as an actual number, where you just take the magnitude of it. Okay? It's just that with velocity with no direction is speed. Root 74, nice. Meters per second. And then the bearing, this is where things get a bit more interesting, okay? Now we need to actually draw out what the vector looks like. So if we draw a little coordinate axes like this goes 7 across and 5 down. So our vector looks something like this, where this part here is 5 and this part here is 7. So we need to work out the bearing. Now bearing's always from north, and north is straight up. This is a 90-degree angle, so we just need to work out what this angle is here. Now we have the opposite and the adjacent side. So theta is just equal to inverse tan opposite over adjacent, so 5 over 7, which inverse tan (35.5 degrees). So the actual bearing is 90 plus 35.5, which is equal to 126 to the nearest degree, right? Because remember, bearings have to be to the nearest degree. They're 3-digit numbers, no more, no less. Okay, so that is it for the first section of the exam questions. So those are from a bit ago. You may even see something like that in your textbooks. But now we're going to get on to essentially the 2020 questions. There's 2 of them for vectors, so let's go through that. Okay, so relative to a fixed origin, you have 3 different position vectors, A, B, and C, and we have to work out what A, B is. So again, with A, B, nice and easy, you're taking the position vector of B, right, so OB, and you're taking away OA. Okay, so again, we can use this in a column notation or the IJK notation. Either way, it's completely and utterly fine. So 3 minus 4 minus 2, 5 minus 6. 3 minus 2 gives me 1. Minus 3 minus 5 gives me minus 8. Minus 4 minus 6 would give me 2. Or, again, you can write that as I minus 8j plus 2k. Now part B says, show that the quadrilateral is a trapezium, giving reasons for your answer. So a trapezium is going to have two parallel sides, right? It's going to have, so I mean, assuming it looks like this, it might look something similar. Right? So one of the sides has to be, or two of the sides have to be parallel, not one of them. Okay. So if I have a look at my vector AB, are any of these parallel to them? Well, I look at C and I can see that to go between these, it's a factor of 2. Like if I want to go this way, I times by 2, and if I want to go the other way, I divide by 2. So in other words, OC is equal to twice AB, therefore they are parallel, hence O, A, B, C. Now if that's not convincing enough for you, let's go a bit deeper, right? So are there any other quadrilaterals that have two parallel sides? Well, you may have like a parallelogram, for example. But if I have a look at the other kind of vectors, none of them are parallel. So the only quadrilateral that has only two parallel sides is a trapezium, right? A rectangle and a square have more than that. They have two pairs of parallel sides. Parallelogram have two pairs of parallel sides, etc. Kites, rhombus, etc. They have no pairs of parallel sides. So the only shape, four-sided shape, that has one pair of parallel sides is a trapezium. And as we can see, the only two sides that are parallel are OC and AB. Therefore, it must be a trapezium. I hope that that's convincing enough for you. Now here's where things get a bit more freaky. So the other 2020 question was honestly pretty hefty. Again, it's only 6 marks though. So point C is such that OC is equal to twice OA. So it might be good to just add on this thing here, where that is point C. Okay? And then what we can also do is add a big shape. And it also says point M is the midpoint of AB, so let's draw M. Straight line cuts through C and M and cuts OB at the point N. So I did that perfectly. So what we can do here is just drag these along slightly. Okay. Given that O to A is A, so again I like to label up absolutely everything, and O to B is B. Find C to M in terms of AB. Well, what we know is that O to C is twice OA. So both halves of this are the vector A, right? So to go from C to M, what I'm looking at is I'm going to go from C to A and then go from A to M. Now, I know what C to A is. It's just going to be negative A, right? A to M I don't know, but I know it's going to be half A to B because M is the midpoint. Now how do I go from A to B? Well, if I look at it, AB is just going to be from A to O plus O to B. So in other words, it's going to be minus A plus B, right? Because I'm going against the arrow here and then with it along there. So in total, it's going to be minus A plus a half minus A plus B. So that gives me, so minus A minus a further A is going to be minus 3 over 2A. And that's just going to be plus a half B. And that's it for 2 marks. Now here's where things are going to get a bit more tricksy. Show that ON is equal to this thing where lambda is a scalar constant. So where lambda comes from, it comes from the ratio of this line here. So O to n to b is going to be something like 1 to lambda or lambda to 1, okay? So, if we want to work out what O to n is, that is the same as going from O to C and then C to n, right? Because we need a few different ways to get there to make this work. Right? So in other words, we can make that O to C plus lambda C to m. So let's just work that out, right? So because they all are on the same straight line, it's a scalar multiple. So c to n is going to be just c to m multiplied by some value that I don't know yet. Okay. So the reason why I chose c to m as well, instead of kind of going along this thing, is because we just worked out c to m. Okay, so it's quite useful to use the previous parts. So what we can do here is we can now write out what this is. So O to C is obviously just going to be 2a, and then lambda times all of this nonsense that we have out here. Okay. And now all we need to do is expand this and show that it's the same thing. So in terms of my a's, I'm going to have 2 minus 3 over 2 lambda a, and for b's it's just going to be a half lambda b, which is exactly what it shows, or not shows, it asks for over here. Then lastly, for part C, it says prove that on to nb is 2 to 1. So because we don't know what on is, we can just call it some other letter, mu b, and we know it's going to be something to do with b because it's along the line OB, right? So it's a scalar multiple of the vector b. And what we can do is we can actually equate it to this. Okay? So if we equate that out, then what we can do is, just thinking of the best way to put this, if we compare the a terms, we have 2 minus 3 over 2 lambda equals 0. If we compare the other terms, we have mu equals a half lambda. Okay. So if we start with, I think we start with this one because this one has 2 unknowns. We have 2 equals 3 over 2 lambda. Whoops. So then lambda is just going to be 2 times 2, 4 over 3. Okay. Now if lambda is 4 over 3, using this equation over here, we will get mu is equal to half of that, so that's 2/3. Perfect. So then from there, if you have the ratio of ON so yeah, just comparing that, it's going to be 2 to 1. If you look, the mu is the actual it's the fraction form of the ratio, right? So O to n is the 2, the numerator. N to b is 2 plus something gives me 3, so it's going to be 1. So in other words, we have our final answer. And it looks like everyone's okay with that in the chat, so we can call it there for today. So thank you very much for coming out.